All right, everybody, this is the chapter 22.2. I know it says 22.1 right here, but this is the chapter 22.2 overview. I wanted to start by going over some of the stuff that we got from chapter 22.1 because that carries over throughout the entire organic chemistry world. Okay, so we're trying to give you a really quick, basic understanding of some of the nomenclature, the naming in organic chemistry, so that you can use that when you get to college level science courses, organic chemistry, any biology course, things like that. You're going to see all of this stuff. Okay, so some prefixes and suffixes. It's a whole new language. Okay, so we need to learn prefixes and suffixes for organic chemistry. And in 22.1, you learn about alkanes. Well, alkane is a prefix and a suffix. A-L-K, always means a hydrocarbon, which, if you remember, is made of only hydrogen and carbon. So anything that's made out of only hydrogen and carbon is a hydrocarbon. Okay, A-N-E is all single bonds. So an alkane is a molecule made of only hydrogen and carbon, and it has all single bonds. Okay, now if you're going to state the number of carbons, you have to have a prefix for the number of carbons. So all of these, meth means one carbon. So yes, methamphetamine, meth is going to be a part of that molecule that has one carbon. There is a reason for that name. We shorten it to meth, but meth means one carbon. Okay, so methane is not methamphetamine. It is a one carbon alkane because it ends in ane. Okay, F is 2 carbons, prop is 3 carbons, bute is 4 carbons, and then we get into our standard geometry: pent, hex, hept, oct, non, dec. Okay, if you want to try and memorize these so you know what you're looking at, and like propane versus butane, things like that. Mary eats peanut butter is how I memorize that. It's my little mnemonic device for the first 4. So meth, eth, prop, bute. Okay, and then in 22.1 we also looked at branches of hydrocarbons. So an alkyl group, A-L-K-Y-L, alkyl group. Alk is still hydrocarbon. It doesn't change its meaning just because we change the ending. Okay, but the ending now means it's a branch. So when we say methyl, we're saying that's a single carbon, meth, YL, branch, single carbon branch off of something else. So like methyl propane would be a branch of one carbon coming off of a 3 carbon propane, all single bond molecule. So there is purpose, there is structure to this. It's just it's new. And so that's why I wanted to go over that one more time. Because now we're going to get into 22.2. and we're going to get into places where we don't have all single bonds. Okay, so now we have 2 new molecules here. Alkenes and alkynes. Okay, now still ALK. ALK means hydrocarbon. That's not going away. But alkenes, E-N-E, have at least one double bond somewhere in their structure. And an alkyne has at least one triple bond somewhere in their structure. Okay. If we're looking at a molecule that has both of these things, it's going to be an alkyne. So kind of the priority would be the larger bond. Okay, but we're not going to be going into that much detail in this class. Okay, so alkenes, alkynes. Now we have multiple bonds in our structures, and we're going to name these using that information. Okay, so naming alkenes. Just make sure I'm not forgetting anything here. Okay, so we're going to take some notes on naming alkenes, and alkynes are very, very similar to alkenes. So first I want to write what we're going to do. The name tells you, by the way, these are your class notes, so find this section of your packet, okay? The name tells you where the double bonds are, and that they are double bonds. The name tells you where the double bonds are and that they are double bonds. Okay, so for example, I'm going to put a 5 carbon molecule here. So if you want to draw yourself a 5 carbon molecule, and then I'm going to make the double bond between the 2nd and the 3rd carbon. So I'm just going to go back here and just put another line. So this is now a double bond instead of a single bond. Okay. Okay, so if we're looking at this structure, I have to know where the double bond is. Now, similarly to branches, we want to number our structure so that the bond follows the carbon with the lowest possible number. So if I'm numbering from 1 to 5 this way, 1, 2, 3, 4, 5, the double bond comes after carbon 3. But if I number this way, 1, 2, 3, 4, 5, my double bond follows carbon number 2. So that's the way I want to number to give that bond the lowest possible number for its location. So we're going to use that location, the number of the carbon where the bond follows, okay? So the bond follows carbon number 2, that's my location. In our previous section, we were saying find the number of carbons. 5 is pent. That's still true, we're not changing that. And then in the previous section, we put A and E at the end because it was all single bonds, okay? This case though, this is a double bond, and we need the ending that says double bond, and that's ENE. So 2-pentene would be how we would name that structure, 2-pentene. Okay, I'm going to erase this, so if you need it, pause your video so you can capture it, and then you can't lose it, because now we're going to name, in the same section of class notes, we're going to name one that has more than one double bond. Okay, so now, more than one double bond. More than one double bond. We're going to use di or tri in the middle of the name. Or if it has 4 double bonds, we're going to put tetra in front of the name, okay? So more than one double bond, you use di or tri in the middle of the name. Or tetra in front. And don't ask me why, I didn't make the rules. That says tetra, by the way, in front. Okay, so I'm gonna show you an example, and then we'll move on to the alkynes. Okay, so we'll do another 5-carbon example, but I'm gonna put a double bond after the first carbon and after the third carbon. Okay, so there's my picture. Again, remember, this is not my complete structure. My complete structure, I would have to go back in and add hydrogens to complete the 4-bond requirement for each carbon atom. Okay, but this is a carbon skeleton. So my double bonds are after carbon number 1 and carbon number 3. So 1, 3 are my 2 locations, okay? And we want to say pentene because pent means 5 carbons and ene means double bond, but there's 2 double bonds. So in 22.1, if we had 2 methyl branches, we would say dimethyl. So we're going to say diene to be 2 double bonds. So pent-diene is hard. We're going to squeeze a little a in there for pronunciation. So this is pentadiene. Pentadiene. Okay, so again, locations of my double bonds. Pent is a prefix. That means 5 carbons, which is what we have. Okay, ene is a suffix meaning double bonds. And di is 2. Not 2 carbons though, it's 2 double bonds. So this is 2 double bonds in a 5-carbon molecule, and that's where they are. Okay? Now if I had 4 double bonds in a big long molecule, I might have like 1, 3, 4, 5 tetradecene. And so that's where we put tetra in front when you have 4. But we're not going to get there in this class, especially not in the coronavirus 2020. Okay? All right, so alkyne. Same as the alkene, okay? You can write it out in words again if you want, but it's the same. We're just using a different ending. Okay, so let's just do an example real quick. So we're going to give location and end with YNE. So if I do this example here, I'm going to do 6 carbons, and we'll just put the triple bond right here. Okay? If you want to pause and try it on your own, go for it. But when we number this one, think about which way we want to number it. If I number from left to right, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, my triple bond comes after carbon number 4. But if I number from right to left, 1, 2, 3, 4, 5, 6, my triple bond comes after carbon number 2. Always prioritize the lower number for your triple bond or your double bond, okay? So this is following carbon number 2 if I'm numbering from right to left. 6 carbons, the prefix is hex. Triple bond, the suffix is YNE. Done. Okay? Same thing for multiple triples. That's a lot less common, but if there are multiple triple bonds, we would do this kind of thing as well. Diene, triene, if we had 2 or 3 triple bonds. Okay? Tetra, again, would be in front. Okay, so that's alkenes and alkynes. The lesson check question is asking about saturated and unsaturated. So I'm going to show you that, and then I'm going to do a different video for saturated and unsaturated fats. But please watch that. It is important, and it's going to be part of our quiz content. Okay? So saturated and unsaturated. The words saturated and unsaturated, those are probably part of your vocabulary already, whether or not you could accurately define them before reading this section. But please think of this as full. And in this case, we're talking about full of hydrogen. If I told you to saturate a sponge, you would probably take that sponge and go fill it with water, right? You're saturating it, you're filling it up. So saturated means full of hydrogen when we're talking about organic molecules. So if this is pentane. Every carbon is single bonded to the others. That's how I know it's ane, okay? And then I filled up the remaining gaps with hydrogen. Now, if I go in here and I change this one to a double bond, this is not a possible structure the way that I've left it. Because if I change that to a double bond and I don't do anything else, each of these carbons now has 5 bonds. And that's not structurally possible for carbon. Carbon is stable with 4 bonds. We need to know that, okay? So if I add a double bond there, I have to get rid of some hydrogen in order for my number of bonds to still be viable, okay? So pentene, 2-pentene in this case, because I put it after the second carbon, 2-pentene is unsaturated because I had to get rid of hydrogens. It's not full of hydrogen. It has fewer hydrogens than the maximum possible for a 5-carbon molecule, okay? Likewise, if I make that a triple bond, again, I would have to remove hydrogen in order for this to be a real molecule so that each carbon only has 4 bonds, and this would be 2-pentyne, unsaturated, okay? So when you add a double or triple bond to a hydrocarbon, you're removing hydrogens, and that makes it unsaturated, okay? Now that's going to lead us right into saturated and unsaturated fats, so please click on the next video when you're ready. Thanks!